Today we have to discuss three-dimensional geometry. That's connected. In the three-dimensional geometry, whatever you all have completed related to triangle, circle, and all have completed geometry. You have completed coordinate geometry. You have completed vector. So how three-dimensional geometry is different from all these things? Clear? So we will discuss about in this chapter. We have to discuss about cosines, direction ratios, direction cosines. When a line joining the 2 points, clear? Three-dimensional is simply that you are talking about x-axis, y-axis, and z-axis. Simply that when you can talk about x-axis, y-axis, and z-axis, that you are talking about that you are talking about space also. Is it clear? So in the same manner, you have to go for the clearance of geometric and analytical purposes. Clear? Geometrical and analytical purposes. Is it clear? So when you can talk about the geometrical and analytical purposes, and if you can talk about direction cosines and direction ratios of a line. So if you can talk about direction cosines and direction, if you can talk about direction cosines and direction ratios of line. Direction cosines and direction ratios of line. Is it clear? So, what you are thinking about direction cosines and direction ratios of line? Here we have to discuss about this thing. If you can talk about the direction cosines and directions of this, first of all we have to complete one thing. If you can talk about this one. Is that clear? If you can take this thing, and if you can take alpha, beta, and gamma. Is it clear? If you can take alpha, is it clear? And if you are talking about if you can take this one also, clear? First of all, what we will do? One is y-axis, z-axis, and axis. Here this one x-axis, here y-axis, and this one working as a z-axis. Is it clear? Now we have the points. That one is alpha completed. Now if you can talk about the beta completed, and if you can talk about this one, sorry, then you can talk about gamma also. Is it clear? So what we have to simply show that if you can talk about alpha, beta, and gamma, clear? And if you can talk about this one is r vector, this one is z vector, this one is x vector, sorry, this one is x, and this one is y vector. Is it clear? I, j, and k. Is it clear? So here if you have these unit direction cosines, if are denoted by L, M, and N. Is it clear? So we have, if you can go for x-axis, y-axis, and z-axis. Some authors are relating direction ratio as a direction number. कुछ author क्या करते हैं, direction ratio को direction number से भी show करते हैं. Books की कुछ होता है. कोई भी number, any three number, if you can take any three number which are proportional to the direction cosines of a line are called direction ratios of the line. Direction ratio क्या होता है? कोई भी three number अगर proportional है direction cosine, line की direction cosine की अगर क्या है, proportional है, तो उसे हम क्या बोलेंगे, डायरेक्शन रेशियोज ऑफ द लाइन बोलेंगे. क्लियर? इफ यू कैन टेक द यूनिक डायरेक्शन कोसाइंस L, M and N. अगर आपने L लिया, M लिया, if L, M and N are direction cosines, अगर L, M and N are unique direction cosines होते हैं, if you can take, and if you can talk about A, B, C, direction ratios of a line. Clear? A, B, C, direction ratios of a line. So, what we can say? A equal to lambda L, B equal to lambda N, C is equal to lambda N. Is it clear? A equal to lambda L, B equal to lambda N, C equal to lambda N. Is it clear? So, where if you can talk about lambda belongs to R. Is it clear? Lambda belongs to R. Clear? If you can talk about the A, B, C with the direction ratios of the line, and L, M and N with the direction cosines of the line, then what we have? If you can talk about this one, you will go for lambda equal to A upon L, lambda equal to B upon M, and lambda equal to C upon M. Any doubt at all? Clear? Any doubt at all? So if you can talk about L upon A, and if you can go for this thing, the lambda will be here, this will be this side. Clear? That lambda, this one here, and this will be here. So if you can go for L by A is equal to M by B equal to N by C, how you can take? If you can take it, if you can take K is any number. Clear? If you can take, let A, B, C be the direction ratio of a line, and L, M and N be the direction cosines of the line, then if you can take L upon A, how you can go for L upon A? L upon A, what is the meaning of L upon A? If you can go for this term, that L upon A equal to M upon B equal to N upon C, you can take it equal to A. Is it clear? If you can take L upon A, M upon B is equal to N upon C, which is equal to the what? Simply equal to K. So if this one equal to, say, where K is a constant, everybody know, your assumption that it will be equal to K. Is it clear? So if you can take L equal to AK, M equal to BK and N equal to CK, right? If you can go for multiplication, L equal to AK, M equal to BK and N equal to CK. Can I round up to this point? L equal to AK, M equal to BK, N equal to CK. Is it clear? Alright. Now what we have to do, if you can go for this term, we have L square, M square, N square, which is equal to 1. Is it clear? So if you can talk about L square, N square, L square, M square and N square. If you can talk about, if you can square it, you will get L square equal to A square, A square. If you can give M square, B square, A square. If you go for N square, C square, A square. Is it clear? Now what we have, if you can add all these things, is it clear? If you can add it, what you will get? L square equal to A square, K square, M square equal to B square, K square, and N square equal to C square, K square. Add it. L square plus M square plus N square equal to A square, K square plus B square, K square plus C square, K square. Is it clear? L square M square plus N square is equal to A square plus B square plus C square. Is it clear? If you can take A, clear? So what you are getting actually, that if you can take L square, M square plus N square, that one is equal to K square, A square plus B square and C square. Here what you are actually getting, that L square plus M square plus N square equal to 1 we have. Is it clear? Already we have L square plus M square plus N square equal to 1. If we have this term equal to 1, so if you can put here, you will get that A square plus B square plus C square equal to 1. Is that clear? If you can take it, you will get it is equal to 1. Any doubt up to this point? Now if you can talk about the value of a K square equal to 1 upon A square plus B square plus C square. Now K is equal to, you will get 1 upon root A square plus B square plus C square. This one is the value of K. That one is 1 upon root A square plus B square C square, and any value which is coming from root, it will be both positive as well as negative. Is it clear? So, if you can go from this equation, that from equation number first, where your assumption was, you will take if this all as equation number first. So according to this, what we have? According to this, we have the direction cosines of the line is equal to L equal to plus minus A upon. If you can put the value of a K here, first of all write it if you want to write. From this side, you need to write this side. Okay? Then I will go for any other thing. Root A square plus B square plus C square. You will get m equal to B upon root A square plus B square plus C square. N is equal to C upon root A square plus B square plus C square. Is it clear? N equal to A upon root A square plus B square C square. N equal to B upon root A square plus B square C square. And N equal to root C upon root A square plus B square plus C square. These are the direction cosines of the line. Clear? These are the direction cosines of the line. And it will put plus minus from root. Everybody, this one is the basic knowledge everybody know. So what you are getting, that you are getting either a value of the k will be positive, either the value of the k will be negative. Clear? For any line, if you can take A, B and C are direction ratio of the line, then K, KB and KC not equal to 0. What is the meaning here? Also it's a set of a direction ratio. Is it clear? So in the same way, what you are getting, what I told about the direction ratio. Direction ratio is simply if you can take any three numbers, already number was taken, any three numbers which are proportional to the direction cosine of the given line, then they are called the direction ratio of the same line. तो वे उसके क्या बने जाएंगे? Direction ratios बोले जाएंगे. Clear? So what the meaning of, first of all, then you have a question. Sir, what is the meaning of direction cosine? Direction ratio, clear. That if it will be proportional, that three numbers will working as a direction ratio. Now, what is the meaning of direction cosine? So, if you can take that, as I told in the vector, clear? As I told in the vector, if the directed line is it's showing the direction also. Passing through the origin and makes an angle alpha, beta, and gamma, as I told in the first diagram, alpha, beta, and gamma, with x-axis, y-axis, and z-axis respectively. If it is making, then they are in the category of, they have a direction, they have angles alpha, beta, and gamma. Then cosine of these angles, if you can take the cos alpha, cos beta, and if you can take cos gamma. Cosines of these angles are the direction cosine of the directed line. उस directed line L की ये क्या होंगे? Directions cosine होंगे. Is it clear? Directions cosine of L. Clear? Any doubt up to this point? Any doubt up to this point? Clear? Now we have to talk about the relation between the direction cosines of a line. between direction cosines of a line. We have a new topic, relation between direction cosines of a line. If you can talk about the relation between direction cosines of a line, first of all, what we have to do, we have to make an axis. You have an axis, that axis and y-axis, origin, O. Now what we have, if you can take, consider any line and the line will be equal to RS with direction cosine L, M and N. You can take it R dash. Is that clear? If you can take RS with direction cosine L, M and through origin, draw a line parallel to given line. You have to draw a line parallel to given line which is passing through the origin. So what you will do? You can draw a line. You're clear? If you can draw it. Now, what you have to do? If the line was totally passing through origin, if you can take point P here, and if you can take the point P, coordinates are x, comma, y, comma, z. Is it clear? X, comma, y, comma, z. On this line, if you have taken point. From P, what you have to do? Draw a perpendicular PA on x-axis. From P, draw a perpendicular PA on x-axis. You have to draw. Here it will not like that, it will be perpendicular. But actually all the axes are at 90 degree to each other. So from this point, if you can draw PA, this is perpendicular to the x-axis. Is that clear? This is perpendicular to the x-axis. Now what you are actually getting, that you have alpha here. Is that clear? Now the point P, x, comma, y, comma, z. Let OP is equal to R. If you can take OP is equal to R, if you can take it here. अगर आपने इसको अलग किया यहाँ पे, is that clear? If you can take OAP, if you can take OAP, is it clear? So what we have alpha, clear? Here this will OP equal to R and this will be X. Is that clear? Now if you can go for OP, where OP is equal to R. Is it clear? So if OP equal to R, then if you can talk about cos alpha. This angle, if you can talk about cos alpha. So cos alpha OA upon OP. Clear? Cos alpha is equal to OA upon OP. The same thing here. OA divided by base divided by hypotenuse. Is it clear? So cos alpha is equal to OA upon OP. And everybody know OA equal to X and OP is equal to R. So it will be equal to X upon R. Can you talk about this one? When this will be equal to X upon R, so this gives X equal to LR. How this will give X equal to LR? That, as I told, we have a L, M and N or the direction cosine. The direction cosine, so cos alpha equal to X upon R means cos alpha equal to L, and L means cos alpha, M means cos beta and N means cos gamma. So L equal to X upon R, X equal to LR. Is that clear? So we have X equal to LR. If X equal to LR, in the same manner you will get Y is equal to MR, Z MR. Is it clear? You will get from the same pattern cos beta, and you can go for cos gamma also. So what you are actually getting, again if you can go for x square plus y square plus z square, same if you can do this one, and add this equation and this. So x square plus y square plus z square, LHS. So RHS will be L square r square plus m square r square plus n square r square. Is it clear? X square plus y square plus z square is equal to, if you can take r square common, l square plus m square plus l square. Is it clear? X square plus y square plus z square is equal to L square plus M square plus N. And everybody know L square plus M square plus N square equal to 1. And this one is equal to 1. So what we have? X square plus Y square plus Z square equal to R square. And this one is equal to R square. And L square plus M square plus N square equal to 1. Let's write it. L square plus M square plus N square equal to 1. Product and all. This is the relation between the direction cosines of a line. Any doubt? These derivations are very important for completing the questions. These will not come in examination, but their patterns are important for your upcoming studies. How these things are coming, how this will be. Cosines होते क्या है, क्या कैसे आ रहे हैं, right? Right? Now if you can go for direction cosines of a line passing through 2 points. Is it clear? Direction cosines of a line passing through 2 points. अगर मुझे ये कॉन्सेप्ट नहीं बताना होता इस तरह से, तो it will take only 3 days to complete the 3D questions. But these are important. Direction cosines of a line passing through 2 points. Direction cosines of a line passing through 2 points. Is it clear? Direction cosines of a line passing through 2 points. Clear? Passing through 2 points. Is it clear? Everybody knows, since one and only one line will pass through 2 points, we can determine direction cosine of a line passing through the given point, because only one line will pass through 2 points. Everybody knows that one. And side. You can take y, z, and x. Is it 4? Is it clear? So what we have? We have to go for PQRS. थोड़ा ऐसा ट्विस्ट करके बना हुआ है, तो मैं उस तरह से नहीं कर रहा हूँ, थोड़ा ऐसे रिजल्ट ये PQRS हमने किया और इसी के साथ ये ट्विस्ट करके बनेगा तो वैसे आ जाएगा. Now if you can go for, everybody know, if there is 2 points, one line will pass. और अभी जो डायरेक्ट डायग्राम आपने बनाया तो RS परपेंडिकुलर टू P एंड वे लाइन जो है पैरेलल टू उस लाइन के वे ओरिजिन से पास कर रही थी, तो सेम पैटर्न है. Now what we are doing, if you can take other diagram, यहाँ पे एक और डायग्राम दिया है, और यहाँ पर हमने क्या किया, that इस चीज के छोटे पार्ट को उठाया, इस वाले ये जो पूरा रिजल्ट है उसे उठा के हमने रखा E and A. अब इसमें ऐसा P and A ऐसा ट्रायंगल होगा, रिजल्ट है जो ट्रायंगल दिख रहा है that. Now what we have, अगर ये ट्रायंगल यहाँ पर रहता है ये ऐसे ठीक, तो जो आपको एंगल्स मिलते हैं जैसे ये ऐसे जाएगा, यहाँ पे गामा मिलता है और यहाँ पे कहीं ना कहीं हमें 90 डिग्री है, यहाँ पे क्या मिलेगा, थीटा मिलेगा. मैं शो इज इट क्लियर? गामा मिलता है एंड दैट वी हैव 1 सेकंड, दिस विल बी गामा. अब आपको एक चीज और क्लियर होगा, this angle will be equal to this angle. How? Yeah, alternate angle, right? Is it clear? No doubt at all. अब ये फॉर्मेशन जो हमने किया P and Q and gamma, राइट? हमने इस चीज को पूरा उठाया, ये डायग्राम जो था इसमें से निकाल के यहाँ रखा, इसमें उसी पे लिखा। We have a diagram A and we have a diagram B. One line is passing through the point x1, y1, z1, and second point is x2, y2, z2. We have a 2 points P and Q. Clear? ये एक लाइन है PQ जो पास करी x1, y1, z1, x2, y2, z2. No doubt at all. Now what we will do? If you can take L, M and N with direction cosine of the line PQ. अगर L, M and N आप लेते हैं डायरेक्शन कोसाइन किसका लाइन PQ का, is it clear? And let it match alpha, beta and gamma with x-axis, y-axis and z-axis respectively. It is making x-axis, y-axis and z-axis respectively. So draw perpendicular from P and Q to xy plane to meet at R and S. जो मैंने अभी ड्रॉ किया, क्लियर? फिर वहां से एक परपेंडिकुलर ड्रॉ करी, ये सारी चीजें हमने की है और एक ट्रायंगल बनाया P and Q जिसमें that one angle PQN. If you can take PQN, वहां पे जो एंगल है क्या है, गामा के इक्वल है, अल्टरनेट इंटीरियर एंगल। Now we will use the concept. If you want to draw it because I have to go for a solution. First we will complete in first lecture, right? And after that we will go for a second. So first lecture will over, so right? Clear? Head out to this point. If you can talk about cos gamma from that triangle it will be NQ upon PQ. Cos gamma equal to NQ upon PQ. Is it clear? NQ upon PQ. And NQ is equal to NQ Z2 minus Z1. NQ equal to Z2 minus Z1. That you are talking about that z-axis. X-axis x2 minus x1. Here you have gamma, so it will be z2 minus z1. And z2 minus z1 divided by p. Now ये कोई लाइन है. You have x1, y1, z1. You have x2, y2 and z2. This one minus this one. This one minus this one. And this one minus this one. ये हो रहा है सारा. Is it clear? So if you can take PQ, so it will be Z2 minus Z2. No doubt. Z2 minus Z2. Is it clear? Cos gamma is equal to NQ upon PQ, that one is equal to Z2 minus Z1 divided by PQ. Is it clear? Z2 minus Z1 divided by PQ. Now if you can go for a cos alpha, in the same pattern you will get cos alpha equal to x2 minus x1 divided by PQ. Is it clear? And if you can go for cos theta, it will be y2 minus y1 divided by PQ. Is it clear? Y2 minus y1 divided by PQ. PQ. Is it clear? Hence, if you can go for direction cosine of a line segment joining the points P, x1, y1, z1 and Q, x2, y2, z2 are. So what you are getting? If you can take cos alpha equal to cos beta equal to cos gamma, cos alpha equal to cos beta equal to cos gamma. So what you can write it simply, it will be written is in the form of that x2 minus 2 minus x1 divided by pq is equal to y2 minus y1 divided by pq equal to z2 minus z1 divided by pq. Is it clear? x2 minus x1 divided by pq is equal to y2 minus y1 divided by pq equal to z2 minus z1 divided by pq. And it out up to this point. Now if you can go for pq, right? If you can go for a pq, what you will get? This one. These are equal. Clear? So we have a point. We have a cos alpha. This one cos beta and cos gamma. So if you can write it like this, x2 minus x1 of p1, y2 minus y1 upon p1, z2 minus z1 upon p1. Now what we will do from here? If you go for a pq, so pq means what? You are actually what you are doing. PQ is the that you are talking about the distance, right? So PQ equal to what you will take from here. If you can take that PQ equal to root, if you can take equal to root x2 minus x1 whole square plus y2 minus y1 plus z2 minus z1. Let us check what we have. x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Is it clear? Because when you can do one thing, then this all is equal to PQ. So it will be equal to K. Is it clear? And as I told that the value of PQ is root x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. And in that also I told x square plus y square plus z square. The base will be like that. Clear? So if you can talk about the direction ratio of the line segment joining P and Q and the points are x1, y1, z1 and x2, y2, z2 may be taken as x2 minus x1, comma, y2 minus y1, comma, z2 minus z1 or x1 minus x2 minus y1 minus y2 and z2 minus z1 minus z2. These are the direction ratio of the line when line passing through the 2 points and the coordinates are x1, y1, z1 and x2, y1, z1. At that time, the direction ratio will be x2 minus x1 or x2 minus x1, y2 minus y1, z2 minus z1. Now, note out better. Or x1 minus x2, comma, y1 minus y2, comma, z1 minus z2. Note out better. No problem better. Clear? Clear? Any doubt? We will talk about one question more, that if a line max on the same pattern, we have a question. This one is the last question of the lecture number first. If I can take one example, we have, if a line max angle 90 degree, 60 degree and 30 degree with positive direction of x, y and z. Positive direction is got both positive and negative there, right? So if line max 90 degree, 60 degree and 30 degree with positive direction of x, y and z axis respectively, find its direction cosine. So you have to find डायरेक्शन कोसाइन, डायरेक्शन कोसाइन। आपको क्या फाइंड करना है? डायरेक्शन कोसाइन। You have to find direction कोसाइन. So for this we have as I know, and everybody knows that direction cosine of the line, if you cut L, M, and the unit direction cosine. So L equal to cos alpha, M equal to cos beta, and N equal to cos gamma. So L equal to solution is equal to L equal to cos 90, M equal to cos 60, and N equal to cos 30. What the value of cos 90? 0. Cos 60, cos 30, 1 by 2, root 3 by 2. Is it clear? So what do we have? If clear, simple, and it was simply that you were talking about the positive, not the negative terms. Is it clear? Any doubt about this one? So this one for the first. We will go for a second one also.